15.6, solving what we so-called the radical equations. So um, these type of equation will contain square roots or it can contain cube roots. So here are the methods for solving equations with radicals. So what we want to do is very similar to it's almost very similar to solving for absolute value equation. We got to isolate one of the radical term on one side of the equal sign. And then once we done that, then we can raise both sides of the equation to the power corresponding to the index over the roots of the radical. So if I'm dealing with a square root, that means I will square both sides. Remember, this is saying squaring both sides, not squaring one term at a time. Okay, squaring both sides. All right, I will show you here just in a minute. If the equation still contains radical, repeat step 1 and 2, then we can solve it according to what type of equation it is. Okay, and then we're going to check all the solutions. Sometimes one of our two solutions maybe can actually does not satisfy the equation, so we cannot use those. All right, so solve the following radical equation. So this is a very easy problem. This equation only consists of two terms. So here my radical term is already by itself. Okay, so once it's by itself, then I can get rid of the square root by squaring both sides. Okay, we'll do sides at a time. Why do I square both sides? So square and square root can cancel each other out. So the left side should just have 4 plus u. Oh, sorry. The right side should be 3 squared will be 9. So now this is a linear equation, so we will solve it accordingly. Since my variable term is positive u, it's positive, let it stay, so we simply move the positive 4 over, which will become negative 4, minus 4 on the other side. So my answer, sorry about that, got to equal to 5. All right, so if I were plugging 5 back into my original equation, 4 plus 5 is 9. Square root of 9 is my original 3. So this answer is correct. All right. Back in module 15.1, we mentioned something about can never have a negative inside the square root. Okay? Because normally when I take a square root on both sides, my answer is going to be positive. Other than the idea of a principle of a square root property, most of the times inside of an even root's got to always be positive. So what I mean here for this second problem is my square root, okay, can never equal to a negative answer. All right, because when I take a square root on both, when I take a square root of anything, my answer should always be positive because negative can never be inside. Negative can never be inside of an even root. Okay, so it got to be a positive answer. So by having an answer equal to negative here does not make any sense. So this example will be no solution. All right. Now, other than the principle of square root property, okay, but that's not what we're talking about here. So, if you are solving for an even root, the other side, make sure it's always going to be positive. All right. Now, cube root is okay. R root, you can actually have a negative inside the R root. So odd root is okay to equal to a negative. So since my radical term, the cube root here is already by itself, all right, now I can just cube both sides. Because cube and cube root will cancel out. So the left side would just be 5 plus 9t. The right side, negative 9 to the third power. That means parenthesis negative 9 to the third power should be negative 729. All right, my variable term, positive 9t is positive. Let it stay. Let's move the positive 5 over to the other side. So that gives me 9t equal to, positive 5 come over, become negative. So that'll be minus 5. Negative 734. Divide both sides by 9. My answer, let's turn it into a fraction. The negative 734 over 9. All right, so I'm going to check this. I'm going to substitute this answer back into my equation. So if I do 5 plus 9 times negative 734 divided by 9, inside this cube root will be negative 729. So if I take a cube root, math number 4, cube root of negative 729, then my answer got to be negative 9. So this answer is legit. All right. Now this example is on the left side, I actually have two terms, my radical term and a positive 3. So this problem is a square root problem. So I need to isolate my radical term. So this positive 3 got to be moved over to the other side. So remember now, my square root, my even root, got to equal to a negative. Okay, got to equal to a not negative. They got to equal to a positive number on the other side. So this square root of negative t plus 5, positive 3 come over, become negative. So 4 minus 3 will be a positive 1. So far, this equation is good to go because the other side is positive. All right, once this radical term is isolated, we can now square both sides. I square both sides because square and square root will cancel out. That will leave me with negative t plus 5 on the left side equal to 1 squared means 1 times 1, which is still going to be 1. So my variable term is negative, so let's move it to the right, become positive 1t. So that means this positive 1 got to go to the other side, become minus 1. So 5 minus 1, t equal to 4. All right. So if I were plugging this positive 4 in the parenthesis inside the square root, that will become negative 4 because t become 4 with a negative sign in front. Negative 4 plus 5 is 1. Square root of 1 is 1. 1 plus 3 equal to 4. So this answer is actually correct. Now this example where I have two radicals equal to each other. So in that case, then if you think about it, each radical term is already by itself. So now what I can do is just squaring both sides at one time. So each square and square root will cancel out. All right, so that leaves me with negative 5w minus 9 equal to negative 3w minus 3. Okay, so this equation only consists of two terms, even though the one above it looked like a 3-term equation, but the reality is the positive 3 and positive 4 are like terms. So once I combine them, I'm still down to 2 terms. So 2-term equations are much easier to solve because now I'm just going to solve these linear equations accordingly. So negative 3w is bigger than negative 5w. I'm going to move my negative 5w over. Sorry, my pen is a little bit acting up today. Move this over. Move the negative 5w over. So that means the negative 3 got to go to the left side. So on the right side, negative 3w is still the same. When the negative 5w come over, it becomes positive. On the left side, negative 9 still negative 9. Negative 3 come over, become positive. So combine like term again. This is 2w equal to negative 6. Divide both sides by 2. My answer, negative 3. All right, so let's plug in negative 3 in here, okay? So negative 5 times negative 3 minus 9. Let's see what that is. And the other side is negative 3 times negative 3 minus 3. So let's put this in the calculator. Negative 3 times negative 5 minus 9. Negative 5 5 times negative 3 minus 9 is positive 6. So this is going to be square root of 6. Does that equal to the other side? Negative 3 times negative 3 is positive 9. Positive 9 minus 3 is negative. It's going to be positive 6. So square root of 6 equals to square root of 6. That means my answer is legitimate. All right. Now, this is one of my favorite questions because this is actually 3 different terms. The t plus 4 cannot be combined. All right. So let's take a look. My radical term is already by itself. Right side, I got 2 terms. So this must be time. So now it must be time to square both sides. So when do I square both sides? When the radical term is by itself on one side. So be careful now. This is squaring both sides. So these 2 terms is going to be both of them being squared. So as you can recall, t plus 4 whole thing squared is never going to be t squared plus 16. That's actually extremely wrong. So here, when you see t plus 4 whole thing squared, this is actually going to be the perfect square binomial, where a plus b whole thing squared is a squared plus 2ab plus b squared, exactly like we introduced before in other module. So by now, hopefully you can just look at this and tell what is t plus 4 whole thing squared is once you memorize the formula. So once you memorize the formula, my a is the t, b is the 4. So if we just do this by looking at the formula, that will be my a squared plus 2 times my a times my b. 2 times t times 4 is going to be 8t. Plus my b going to be squared, which is 16. Okay, that will be the answer for that side. So the left side, square and square root cancels out. That just leaves me with 9t plus 22. So now by looking at this equation, this is actually becomes a quadratic equation. All right, so for module 13, okay, solving for quadratic equation is where by factoring is where one side got to equal to 0. So since my leading term t is already t squared is positive, I'm going to move my 9t and positive 22 to the other side. And I'm going to go ahead and combine them as well. So the left side is 0. T squared still t squared. Positive 9t come over become minus 9t. So 8 minus 9 is negative 1t. Positive 22 come over become negative. 16 minus 22 is going to be negative 6. All right, so let's factor this. So for t squared, I can use t and t. For 6, okay, I'm going to use 2 and 3 because if I use 1 and 6, that means the difference will be 5, not 1. All right, so now my outer is 3, my inner is 2. Okay, to end up with the 1 in the middle, my last sign got to tell me how to get. My last sign tell me my inner and outer got to be subtract to get my middle term. And my last sign also tells me the choices for the sign in the parenthesis got to be 1 positive, 1 negative. So to end up with the negative 1 in the middle, I got to give the negative to the bigger of the 2 inner and outer. So that means the outer got to be negative 3 by t times negative 3. The other one is positive. Now, once I factor, set each factor equal to 0. My answer, t equal to negative 2. The other t is equal to positive 3. Okay, so let's check our answer. Okay, let's check our answer. If I plug in negative 2 for my t, negative 2 plus 4 is a positive 2. 9 times negative 2 plus 22 is going to be 4. So this is going to be a square root of 4. The other side is going to be positive 2. Square root of 4 is 2. So this answer is actually okay. I check with 3. Okay, let's check with 3. If I plug in positive 3 for the t, 3 plus 4 is 7. All right, the other side is going to be square root of 9 times 3 plus 22. So 9 times 3 plus 22 is 49. So this is going to be square root of 49, which is 7. So both my answers are legit. All right. So in this lecture video, we talk about how to solve equations involving with radical. Got to first isolate the radical term first before we can square in both sides or cube both sides. All right. That will conclude this lecture video. Thank you for watching.